Hello students, I am Dr.A.K. Sinha. I will continue from the last class. Last class I discussed polarity of bonds. Now I am going to discuss the valence shell electron pair repulsion theory. That is called, in short, it is called VSEPR theory. Again I am telling topic, the valence shell electron pair repulsion theory. In short, it is called VSEPR theory. It is very, very important. Now I am just continuing this. I am going to start VBT, not VBT, VSEPR theory. Lewis' concept is unable to explain the shape of molecules. Why does this theory has come? Because Lewis' concept was unable to explain the shape of molecules. VSEPR theory provides a simple procedure to predict the shapes of covalent molecules. Sidgwick, scientist, Sidgwick and Powell, these were two scientists, in 1940 proposed a simple theory based on repulsive interaction of electron pairs in the valence shell of atoms. It was further developed and redefined by two scientists in 1957. Their name was Nyholms and Gillespie. Actually, these names are asked in UPSC examination. That's why name and year I am telling, sometimes in your examination also. The main postulates of VSEPR theory, I am telling you, these postulates are most important. What are these postulates? Means just like assumptions, it was considered. Then what are the postulates? I am going to tell. First, the shape of a molecule depends upon the number of valence shell electron pairs, may be bonded or non-bonded, around the central atom. This is the first point. Again I am telling you, the shape of a molecule depends upon the number of valence shell electron pairs, may be bonded or non-bonded, around the central atom. This is the first point, first postulate. Second postulate, pairs of electrons in the valence shell repel one another since their electron clouds are negatively charged. Then you know that in same charge repulsion. That's why pairs of electrons in the valence shell repel one another. Now third point, third postulate. These pair of electrons tend to occupy such position in a space that minimize repulsion and thus maximize distance between them. These pairs of electrons tend to occupy such position in a space that minimize repulsion and thus maximize distance between them. They will minimize repulsion only, then they will be far from each other. And in a space they will arrange like that way, so that repulsion should be less, and when repulsion will be less, then automatically distance will be more. Fourth postulate, the valence shell is taken as a sphere with the electron pairs localizing on the spherical surface at maximum distance from one another. The valence shell is taken as a sphere. Valence shell, just to listen. The valence shell is taken as a sphere with the electron pairs localizing on the spherical surface of maximum distance from one another, so that repulsion will be less. Now, fifth postulates. A multiple bond is treated as if, means just like, a multiple bond is treated as if it is a single electron pair, and the 2 or 3 electron pairs of a multiple bond are treated as a single super pair. If it is more than one pair, means 2 pair or 3 pair is there. In multi-pair, in multiple bond, you know that 3 bond will be there, means 3 pair. The simply it is considered as if it is more than one, then it is considered as a super pair. Now, last postulates. When 2 or more resonance structure can represent a molecule, the VSEPR model is applicable to any such structure. Sometimes it 2 or 3, you can say, resonance structure will be there. When 2 or more resonance structures are there, any structure represent, you can say, any structure is applicable to any structure. Means VSEPR theory is applicable for any structure. Suppose 3 are there, then for each structure. I have told you that finally one equivalent structure is there, that is considered, that is also okay, but VSEPR apply for each, for any or for each, you can say, a structure. This I have told about this assumptions of VSEPR theory. This is very, very important, most important. Now, next very important concept I am going to tell. Only on that basis you can tell the shape of the molecule. Very, very important. Only this is the main things of VSEPR theory. This concept, what are that? Listen carefully. The repulsive interaction of electron pair decreases in the following order. The repulsive interaction of electron pairs decreases. How they will decrease? Then in the following order. There are 3 pairs are there. You listen carefully. Lone pair is one thing. After that, bond pair, because electrons will share and make the bond. That is called a bond pair. Lone pair, they are not taking part in bond formation. Then these things you keep in mind. Then now I am telling the order. Lone pair, sometimes there may be 2 or 3 lone pair also. Sometimes a lone pair may be 3 also, 2 also, 1 pair also. 1 pair means 2, 2 pair means 4, 3 pair means 6. Generally 2 pair will be there. Okay. Then now I am telling you lone pair. In shortcut it is telling LP. LP means lone pair. Then lone pair repulsion is greater than lone pair bond pair repulsion, because lone pair they themselves will repel. Then that is you can say greater. Lone pair is greater than lone pair bond pair, and lone pair bond pair is greater than bond pair. Just simply you think Just like one molecule AB2 means A is in the center and both sides BB are there. Then suppose on A one pair electron is there. After that AB one bond, other bond is again AB. Then two bonds are there and one lone pair is there. Then lone pair, suppose two lone pair was there on A. Then lone pair repulsion will be more than lone pair bond pair. And lone pair bond pair will have more repulsion than bond pair. Means suppose on A two pairs are there, then they will repel more than A and B bond is there. Two bond will be there, AB. Then there it will be little less than lone pair. Means lone pair bond pair is less than lone pair. And lone pair bond pair is further less than more than lone pair is more than lone pair bond pair, and this is more than bond pair. That you keep in mind. That's why it is written as lone pair is greater than lone pair bond pair, and lone pair bond pair is greater than bond pair. Correct? These things remember. Okay. And two scientists, Nyholm and this Gillespie, in 1957 refined the VSEPR model. This model they have refined. What I told you now, that lone pair is greater than lone pair bond pair, and this is greater than bond pair. They have refined they have done by explaining the important difference between the lone pairs and bonding pairs of electron. While the lone pairs are localized on the central atom, always lone pairs are localized on the central atom. Each bonded pairs is shared between the two atoms. Correct? That is you are knowing sharing of bond, the sharing of electron. Then lone pairs are localized on the central atom. Each bonded pair is shared between two atoms. As a result, the lone pair electrons in a molecules occupy more space as compared to the bonding pairs of electrons. Here you have to understand, because lone pair is in the central molecules. Then both from both side, from the bound side, suppose the left side, right side bond is there, and in the middle central atom is there, they have lone pair. Then from the both side also it is going to be repelled. Lone pair, they themselves are repelling to each other, and other repulsion is due to the bond pairs. That's why they will get more repulsion. Hence, they will make more distance. They will make more distance in space because of more repulsion due to lone pair and bond pair. Okay, that's why in a space they will make little more distance in comparison to bond pair. Okay, then you should understand this point. Lone pairs are localized on the central atom. Each bonded pair is shared between two atoms. As a result, the lone pair electrons in a molecules occupy more space as compared to the bonding pairs of electrons. This results in greater repulsion between the lone pairs of electrons as compared to the lone pair, bond pair and bond pair repulsion. These repulsion effects results in deviation from the idealized shape and alteration in bond angles in molecule. Due to this effect, what I told you, that it will what we are thinking that shape should be like that way, but due to this repulsion there will be deviation in ideal, what we are thinking in the simple way, that shape should be like that is the ideal, theoretical, but actually it will deviate from that shape due to this repulsion. Due to this repulsion, what I told you, means lone pair, lone pair, lone pair, bond pair, bond pair, bond pair. They will deviate from the ideal shape. Now, for the just I am telling you further, for the prediction of geometrical shapes of molecules with the help of VSEPR theory, it is convenient to divide molecules into two categories. Two types of molecules you have to consider to understand better. First, molecules in which the central atom has no lone pair. And second, molecules in which the central atom has one or more lone pair. Okay, actually I will try to give you some shape of molecules, separate sheet. I will try to give a shape of the molecules, a diagram. In the video I will try to give some diagram of molecules. Okay, then you will understand very clearly, but now I will try to explain. Okay, then if you will see the diagram, many molecules are there, distorted molecules also there. You will find three things in the diagram. You will find three things you will find. First things you will find number of electron pairs, and after that, in that you will find arrangement of electron pairs. What are the angle between the two bond, that you will find. Third things you will find molecular geometry, like that way, whether it is a linear, means a straight line, or trigonal, planar, means triangle shape, or tetrahedral, or trigonal, bipyramidal, or octahedral, like that type of shape, molecular geometry, what we are telling, you will find. Okay, this is the third point you will find an example in which molecules exist. Okay, again I am telling you four things you will find that in that structure. First, number of electron pairs in that molecules. How many electron pairs are there, that you will find. After that you will find arrangement of electron pairs, angle, what angles are there, that you will find. Third things, that molecular geometry, whether it is linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral, like that way. And example of molecular geometry. Okay, like in which molecule this type of shape is found. What are the example of that molecule? Then these four things you will find in case of when no lone pair of electrons are there. In that molecules, if no lone pair, means category 1, what I told you, you will find. If no lone pair of electrons, then their shape will be ordinary shape, ideal shape. But when there will be lone pair, one lone pair for more than one lone pair, then that time you will find a special shape. A special shape means deviation from the original shape. Then there what you will find, you can say in that shape you will find, you have to consider 6 things, point you have to consider in that. When you will see the structure, then 6 point you may find. First, molecular type. Molecular type means, as for example, I told now maybe AB, AB2, AB3, AB4, AB5, AB6. Type of molecules last class I have discussed. These types are telling about AB means 2 atom, AB3 means 3 atom, AB4. AB3 means 3 plus 1, 4. AB4 means 5. AB5 means 6. Like that way, this is telling about the molecular type. But here, in this case, when lone pairs are there, then because lone pair will be there, the lone pair you can indicate by E. E means electron pair, capital E. Then you will find that AB, as for example, AB2 is there, then and one pair is there, then it will be written as AB2E. If AB3 is there and one electron pair is also there, how many, that is different, but electron pair is there, then you can write AB2E. If 3 are there, AB3E, AB4E. E means electron pair. AB4E, AB5E. If generally if two lone pairs are there, then you can write E2. E2 means, if suppose this is there, AB2E2. AB2E2. E2 means 2 pair of electron, a 2 pair of lone pair of electron. If only 1 pair of electron is there, then you can write AB2E. AB2 means total 3 atoms, A and 2B, and 1 lone pair of electron. But AB2 is there and that 2 lone pair of electron is there on B. It is possible 1 pair also, 2 pair also, then E2 write. Understood? Then you can understand like that, AB2, E2. Okay. Like that way, AB, AB4, AB4E. AB, AB3, AB3, E2. Like that way, you will find. Okay. E means lone pair of electron. If one electron lone pair, if one electron pair is there, lone pair 1, then only E. If 2 lone pair is there, then E2. If like that way, it will be written the side. And second thing, you have to find number of bonding pair. Number of bonding pair. How many bonds are there? That you have to consider. Third things, number of lone pair. You have to consider whether it is 1 pair or 2 pair. And fourth things, arrangement of electron pair. Arrangement of electron pair. All will be not only in one place. Arrangement of electron pair. And next things, shape. Means fifth point, you have to think shape. What is the shape? Bent shape, trigonal, pyramidal, seesaw, SEESAW, seesaw shape, T shape, square, pyramidal, square, planar. These are called shape. What is the shape? And last point, 6 points, that is the examples. In which molecules these things are found? What are the example? Which example has bent shape? Which example has AB2E, number of bonding? Like that way, examples of that molecules. Examples may be O3, SO2, NH3, H2O, SO4, ClF5, like that way, BRF5, Xenon, HCFO, maybe so many examples. Okay, then when I will provide the diagram of this type of molecules, then this point you have to consider. Then you will understand very quickly. It is very easy to explain all the things. Okay, and after understanding this concept, it is very easy to write the structure also and to answer this also. And I will give you can say some technique or some tips. Okay, how to understand fast. Now just you understand that you will find all these things diagram we will provide, in that you can see the shape. But now you try to think in mind, imagine in mind. This is very, very helpful. Imagination, if you are knowing how to imagine the things, it means your brain power is increasing, means analyzing capacity is increasing, and it is a good mental exercise. Okay, you will feel in the beginning difficult, but later on you will find easy, and it is very, very helpful in every sense. Okay, now just understand linear structure. Already told you, linear structure means a straight 180 degree angle will be there. Suppose type is there AB2, already I have told you. Linear structure AB2 180 degree it is making. If it is if AB2 means a straight line, okay, generally it will be a straight line. Sometimes it may show V shaped also. Now if it is a AB3 means A in the middle and 3 bonds are there. Okay, then between the 2 bonds, total 3 bonds are there. AB. Then between the 2 bond, 120 degree will be there. Then 120, 120, 120. Total 360 degree, you know. In mathematics also, total bond will be everywhere in space. That is the 360 only. Then here, if AB3 is there, means 3 bonds are there, then you can understand that 120, 120, 120 degree. If you can say now 4 bonds are there, AB, then angle will be 109.5 degree. Keep in mind, in methane, tetrahedral, what we are telling, tetrahedral, when this type of shape will be there, then it will be tetrahedral. In case of, I told you example, CH4, 109.5 degree. And here also you can understand, if example of the when AB3 example 120, for that BF3 boron trifluoride, and 180 I told you first example, then BeCl2. Okay, that is the example. Now if it is a 5, means central atom 3 to 5 atoms are there, total 6 including central atom, it is 6. That is the AB5. Then here 2 types of angle will be present. In AB5 2 types of angle will be there. 2 types, 90 degree and 120 degree. Then this angles, actually due to this angle, shapes depends upon these angles. Then I have told you about this some shape according to the angle. Linear, trigonal, planar, tetrahedral. If I told you AB2 is there, total 3, AB2 a straight line, 180 degree means linear. And trigonal, planar, when 120 degree angle will be there everywhere, 120, 120, 120, that time it is called trigonal planar. If 109.5 degree is there, then that is called tetrahedral. And if it is a 5, AB5, then that time it is called trigonal bipyramidal. Correct? Then linear, I told you linear. Second, I told you trigonal planar, 120 degree, if it will be there. And after that, tetrahedral, when 109 degree will be there, 109.5 degree. And trigonal bipyramidal, if 5 are there, like that way, octahedral will be also there. Okay, that is a AB6. If AB6 are there, then octahedral. Now again you listen. The VSEPR theory is able to predict geometry of a large number of molecules, especially the compounds of p block elements. Accurately it will tell. It is also quite successful in determining the geometry quite accurately, even when the energy difference between possible structure is very small. Quite accurately, even when the energy difference between the possible structure is very small. So that's why I am telling you, in resonance, each resonance structure, on each resonant structure, VSEPR theory applies. The theoretical basis of VSEPR theory regarding the effects of electron pair repulsion on molecule shapes is not clear. Can you understand? The theoretical basis of the VSEPR theory regarding the effect of electron pair repulsions on molecular shapes is not clear and contribute to be a subject of doubt and discussion. That's why new theory has come. New theory that is called valence bond theory, VBT. VBT also has limitation. Then last theory has come, that is called MOT, molecular orbital theory. Okay. Then in every time some improvement went. I will tell you, you can say all the things. When time will come, slowly and slowly, at a time you can't understand. Then now today I am stopping only here. Again I will discuss, you can say, some explanation which of the some molecules which is asked in IIT on medical. Okay, and that I will discuss in the next class. Thank you.